Hi grade 11s, welcome back to another one of our video lessons. So today we're going to start with topic 8, which is on page 174. We're going to begin with unit 1, which is plans, and the entire chapter is titled Maps, Plans and Other Representations of the Physical World, Plans and Models. So after we look at house plans, we're going to look at layouts of theaters and shopping malls and understand how those work as well. Alright, so let's begin with plans for houses. So when building or renovating a house, it is wise to have plans drawn to scale. On plans of buildings, north will always be indicated. When building a house in a particular area, the direction of the prevailing winds and rain must be taken into account. The direction of sunlight is also an important factor to consider. In South Africa, if a building faces south and there are tall structures to the north of the building, it will be very cold and dark in the building. All right, guys, so let's go through that a bit, right? So, firstly, they say plans should be drawn true to scale. Why? Well, because they're going to provide municipality and you and contractors with the information about your house, and that will tell you how many tiles you're going to need to floor your area, how many liters of paint you're going to need to buy, how many roof tiles you're going to need to replace your roof, because contractors will come to your house and say, oh, you want to replace a roof, how many square meters is it? Oh, 55, okay, this is the cost. Okay, so you need to be able to work out accurately the square meters of your roof. Okay, right, then they say that the direction will always be shown on your house plan. Why is that? Well, as they said, it is important which way your house faces, right? Meaning that where your curtains open up and where, let's say, your bedrooms are. Okay, so if my bedrooms are facing south, the sun rises from east to west, but behind me. Okay, remember we're in the tip of southern hemisphere, so the sun rises more from the north side than the south side. Okay, so if we're facing south, we're already not getting any sunlight coming in. And if there are tall structures facing north or to the north of our house, that means that's going to be blocking out the sun that's going to be coming in. So you're going to have a really cold house. So imagine you bought a piece of land and that's one aspect that you forgot to think about, or it never occurred to you that this could be the way things work, and you build your house, and once it's done and you're living in it, you realize, well, my house is actually dark. There's mold everywhere because there's no sunlight coming in. It's cold. I need to spend so much on electricity. And your neighbor next door has a beautiful house which is turned around and they're just chilling out in the sun. They don't have any of these problems. Okay, so that's basically what the issue with house plans is. So now we're going to learn how to read a house plan, what are the different markings on it, and how do we use the scale of the house plan. Okay, so the diagram below shows a floor plan for a house used and a northwest elevation plan of the same house. Use the figures below to answer the questions. Okay, so if we're looking at figures below, so I only see one figure below in the worked example, and the little diagram on the left is not the same house we are looking at. So I'm not quite sure what they are saying with the northwest elevation, but it's fine. Let's now look at the house. So number one, what is used to represent doors on the floor plan? Okay, so try to spot a door. All right, and I can see one there where it says entrance. Okay, so a quarter circle is used to represent the door, and the arc of the circle represents where the door is going to be swinging. Okay, number two, what is the real dimensions of the bedroom? Okay, so they give us a scale there. Remember, we've done scales before. So what we're going to do is we're going to first measure the bedroom, get its measurements on the plan, and then use the scale to find real measurements on the real ground, okay, or on the ground. Okay, so if we now take our ruler and put it down on the scale that they have provided us, okay, what I notice is that one centimeter measures 1.5 thousand centimeters in real life. Do you see that? So put your ruler down 0 lining up with 0, and look where 1 centimeter is on your ruler. It's between 1000 and 2000 mark. Okay, so 1 centimeter on the map is 1500 centimeters on the ground. Okay, so the scale is 1 to 1500. Okay, great. Now what we're going to do is we're going to measure the bedroom with our ruler. Okay, so I'm going to measure the outside walls of the bedroom. Okay, not on the inside, I'm going to do the outside. So I get 35 millimeters or 3.5 centimeters. Okay, so my length equals 3.5 centimeters. Okay, my width equals 2. Let's measure that. And I get 20 or 2 centimeters. Okay. Now we have to apply the scale to these measurements. So 1 is to 1500. Here we got 3.5. So we just multiply it by 1500. So the real length equals to multiply by 1500. Well, let's quickly use a calculator. 3.5 times 1500. Okay, I get 5250 centimeters. Okay, and my width is 2 centimeters times 1500. That's going to be 3000 centimeters. Okay, guys, I'm looking at the solution there, and I don't understand where they got 4500 and times 2625. I've measured this twice. I've went through this example, and I don't think their solution is correct. Okay, but maybe they measured on the inside of the walls, but I went for the outside. It shouldn't change the answer by that much, so it could be just a mistake. But I'm happy with the way we did it when we got the scale out and we multiplied the lengths. Okay. Number 3, what is the length of the kitchen dining area? Okay, so what is the length of kitchen dining area? Okay, so what they're asking for here is, well, the length probably in real life. So let's quickly measure that. Kitchen dining room area, I get to be 4 centimeters. Okay, 4 centimeters. If we apply the scale, 4 times 1500 will equal to 6000 centimeters. If we convert this to meters, it is 60 meters. That sounds way too excessive. So I don't know if they've given us the correct dimensions, because the scale looks way too big. So for 1 centimeter is 1500 centimeters on the ground. I don't know, unless this is like a ginormous house where, you know, your kitchen and dining room area is 60 meters, so that's 30 meters each. Looks very big. Okay, but guys, this is the solution they've given us. I don't know what to say. They don't give us any workings. Then we could see if we're getting our scale correct, but according to the scale that they've provided us, that's what it is. Okay, all right, so unless they mean 1 centimeter is 1000, then let's see if that works. So for number 2, what are the real dimensions of the bedroom? We had 3.5. No, it still doesn't work, because they get an answer of 4500, and if we use even 1000, we'll get an answer of 3500. So I think something is wrong here. Okay, unless they're using the other house, but I don't think that's right. Okay, anyway, let's continue. Let's do it our way, and we'll see how exercise 1 goes. Right, what is the length of the kitchen dining area? We got that. Number 4, what are the real dimensions for the length of the bath? Okay, what are the real dimensions for the length of the bath? Okay, what we're going to do is we're going to, with our ruler, we're going to measure the bath. I get just over 1 centimeter. So let's see if I can get a better reading. Look, I'm happy with 1 centimeter. 1.1 is a little bit too much. Okay, so what is the real dimensions for the length of the bath? We get 1 centimeter. We put that 1 centimeter onto our scale and we get 1,500 centimeters. If that's the scale that they're using, the bath is 15 meters, which again doesn't make sense. Okay, so I think the scale is really, really wrong. They get 1,375. Okay, so if we divide that by 10, we get 137. So the scale that they are using is 1 to 137, not 1,500. Right, number 5. What are the dimensions of the bathroom on the plan? Okay, so when they ask you dimensions on the plan, that's the actual centimeters that we're measuring. Okay, so guys, you can measure that. That's pretty straightforward. 6, what are the real dimensions of the bathroom? We've done that. 7, find the length and the width of the house in reality. Length and width of the house. So that's the entire length going across, entire length going sideways. Okay, so guys, we're going to use our scale. So whatever we measure, we're going to multiply by 1,500. So my width I get is 75 millimeters. And my length I get to be 77. So it's almost a square house. Okay, so we multiply those by 1,500 and we should get our answer. Okay, right, number 8. The northwest elevation of the house is given. Explain where you would stand in relation to the floor plan to see this particular elevation view of the house. All right, so what they're saying is that if we want to look northwest, where am I going to stand to see that view, that northwest elevation of the view? All right, so think of our northwest. Okay, so we have north going that way. Northwest is there, okay? We want to see the northwest elevation, right? So this is the northwest side. So we got to be standing on the opposite side to see the northwest elevation, okay? Because if we talk about the south facing, we're talking about the south side of the house. So if you want to see northwest elevation of the house, we got to be standing here. So if we compare that to the map, right, we're standing to the left, we're standing 45 degrees to the left of north. So if we look at our map, there's north, so we got to turn 45 degrees. So to see the northwest elevation of the house, I would have to stand in front of the entrance, in front of that. It looks like a big glass window, okay, or a wall. But in front of the entrance, where basically the words say of the same house, okay, if you looked in the word example, that would be the northwest elevation. Number 9, if weather conditions have been considered for the drawing of these plans, from which direction do you think the prevailing winds and rain come? Validate your answer. Okay, guys, the same idea with the sun. With the rain, you don't want to be on the side where it's raining and windy because those rooms are going to be cold. So during the night, you want to be warm, right? Usually it's windy at night, right? So, well, not always. So from which side would you justify the wind is coming from? Well, I wouldn't say from the south because the bedrooms are there. All right. I could even say the west or east even, because if we go from west, there's a study and a bathroom. You don't spend a lot of time in study and bathroom. And from the east, we have a dining room. Again, in the kitchen and dining room, it's you cook your food and then you're out. All right. So I would say it's either from one of those sides. Okay. Your outdoor living area is in the front, which is also could be a reason, but it's definitely not from the south. Okay. All right, so Let's see what they say. The rain and prevailing winds come from the southeast direction, and there are no windows or doors on the section of the house facing southeast. Okay, so southeast, we look at there. I don't know, guys. I see a window in the bedroom from southeast direction. So I'm not too sure if we are talking about the same diagram on this picture, because there's clearly two windows in the bedroom on either side. And if north is there, south is opposite. Southeast is going to be between north and south on the right. So I don't know. I'm not quite sure if this example makes sense for us. Anyway, let's look at exercise number 1. Answer the questions using the floor plan and the elevation plans that follow. Okay, so here we have a more detailed plan. We also have 3 side views of the house, A, B, C, and D. Okay, guys, so what I want you to do is work through exercise 1. Try to do this like we did with the previous example. I know the scales didn't work and our answers didn't match up, but I'm not quite sure what exactly the issue with that is. But if you look at your scale in exercise 1, I measure 2.5 centimeters, which is the whole scale, and that gives me 3 meters. Okay, so it goes up to 4 there, but I think they're just missing the little bar. All right, so 2.5 centimeters is 3 meters on the real ground. Okay, so, or on the ground. Okay. Guys, so do exercise 1, and then in the next lesson, we're going to continue with shopping mall floor plans and theater seating plans. All right, guys, I hope you enjoyed the lesson. I'll see you next time.